The last decade, we've seen the rise of cloud computing and how it has taken the technical world by storm. Thus, we see many companies wanting to move their business to cloud and many individuals wanting to make a career in this domain. That is why we see that many cloud service providers coming up and providing wonderful cloud computing services to many organizations and people. One such popular cloud service provider is Google Cloud Platform, which is also the home to popular services like YouTube and Google search engine. Hello all, I welcome you all to this session by Edureka, where we are going to discuss Google Cloud Platform in detail. Let's quickly take a look at the agenda and get started with this video. So first and foremost, we would start by understanding what cloud computing is, which is very core to our cloud platform, that is GCP. Moving on, we'll discuss what GCP or Google Cloud Platform exactly is. Then we'll understand various service domains that GCP has to offer to us, be it the compute domain, storage domain, networking domain, security domain, management and developer tools, big data services, and also machine learning services. While we go through these pointers, I would be also giving you a walkthrough to certain important services when you talk about it from a demo perspective. So let us not waste any more time and quickly get started. Okay, so let's start by understanding what cloud computing exactly is. Now, to understand this, we are going to go ahead and consider a scenario. Now, if you talk about traditional e-commerce services, there are certain things that one considers, right? Let's assume that you want to set up a business that is more related to e-commerce. Now, in that case, these are the things that you'd be more involved in, right? You'd be setting up a server, right, which would basically help you connect to your physical logistics, deployments, and stuff like that, right? And to do that, you'd be needing powerful servers, right? And what do these servers also do is, they not only help you to actually manage these physical logistics data-wise, but what they would also do is help you stay connected to the audience that is there, right? What you also want to do in this business is basically ensure that whatever is happening, people can connect to it through your mobile phones, right? To give you a very common example, let's talk about Amazon or Flipkart in India that we have for e-commerce or e-shopping rather, right? So we have these applications or these websites that are up and running, which can be accessed through your web, but at the same time, you can also access them using your mobile phones, right? So what we are talking about is a centralized business that is spread worldwide and that can be accessed by using various solutions, various applications, right? Or various methods rather. Now, this sounds fairly easy, right? I mean, having a server placed somewhere where basically all your data is residing and you can access that data across the globe by using your phone or by a web service, right? But when you talk about the complicacies, this kind of an architecture is not something that is very easy to set up, right? There are a lot of things that are involved in bringing up this kind of an infrastructure or an architecture rather. Let us just go ahead and understand what are the complicacies that one might face. Well, one of the major concerns here is, let's assume that the traffic that is there with your website, it just shoots up. To give you a very common example, now if you're based in India, you could relate to this, right? We celebrate festivals like Diwali, which are highly popular around the end of October, November, whenever the date it falls on. We tend to have these seasons, these spikes where people tend to shop a lot for these festivals, right? If you talk about other countries, Christmas can be one example where before the Christmas Eve, you would want to shop, right? So during these days, you'd see that there's a spike, right, in the traffic that these e-commerce websites might face. And they literally break down in some cases. That is the demand, because if you talk about these things happening at a global scale, we can imagine the population the world possesses right now, especially when you talk about India. It is one of the biggest markets for the world. So what that does is, let's assume that there's something which is to be celebrated and people want to shop. And if there's a good offer, the server can easily crash. Why? Because the billions of people wanting to basically go ahead and buy that particular product, right? Millions and millions trying to get that product in their hand, basically trying to look through it, browse through it, take a look at the content that is there, right? So that is what is one of the major concerns here. Now you might wonder how. Well, let's take a look at that. So what are the common problems that one could face? Database and security, increased cost, scalability issues, fast and fault tolerant, and managing servers. Now, this is something that we need to discuss more from a technical perspective. We understood the fact that there are many people trying to shop a particular product. What happens at the back end is, basically, let's assume that I have a particular set of servers that is there with me, right? It is adept enough to host a particular amount of traffic. To give you an example, let's assume that my server has a capacity of X petabyte, right? And to which there's a particular amount of compute capacity that I can associate with it. So say, for example, in milliseconds, it processes X number of requests. What happens when this limit exceeds X amount of requests? In that case, there's a high possibility that my server is overburdened. Now, when you set up a server, let me tell you one thing, buying a server is a very costly process. Now, what that means is, if you're investing this much money, you either need to have resources that are in abundance to handle all these requests. But let's assume that I take X plus 10 petabytes of storage and some X plus 10 times the computation power, right? But if there's no spike in my traffic, in that case, I'm underutilizing my resources because I've over provisioned. What that means is, I would be paying a lot more money because I've just mentioned that servers are very costly. So this is where the problem of plenty comes into picture. Let's assume that I under provision it. I say, okay, there could be a possibility that I might need only these many resources. But when spike like the one that we just discussed arrives, is your system capable enough to handle that traffic? No. Again, there's a problem where you might face downtime, you might face server breakage and all those things, right? So what happens here is, server breakage is a wrong term to be used, so forgive me for that. So what happens here is, even in case of under preparation, you are losing out on the business that you wanted, right? You're experiencing downtime. So this is the issue with the server. The other part that we discussed is cost, right? I mean, when you talk about buying these huge amount of servers, you're still paying money. If you're buying smaller sizes and you're losing business, you're again losing money, right? Even after investing this much in servers. Apart from that, if you talk about this hardware, right, there are a lot of complications with it. You need people who can maintain and monitor these servers, which again is a very big problem. Now, this is where a platform like Google Cloud Platform comes into picture. This is where cloud computing comes into picture, and they solve these issues, right? You have concerns like data security, you have cost concerns. Scalability is one issue, the one that we just discussed, right? Never knowing how much is enough. So if you have a system that can scale to your needs instantly, that is where you can actually set up or solve your scalability concerns. And similarly, you want systems that can handle this huge amount of traffic or lower amount of traffic as well. So as I've mentioned, cloud computing is something that would help you solve this problem. Let's try and see how does cloud computing do that. Okay, so this is what cloud computing does. Now, what cloud computing is, I'll come to that point. But before that, let's quickly take a look at what is happening here when you talk about cloud computing. Now, when you talk about cloud computing, what cloud computing does is, it provides you cloud services, or the services that we just talked about, right? Providing you servers, providing you storage, computation, and ensuring that you do not face problems that we discussed. Now, you might wonder, as in, cloud is giving us something that we've already provisioned on ourselves. So how is cloud different? Well, what cloud does is, cloud gives you the freedom to choose in what amounts you want to use these resources, and accordingly charges or bills you for that. So what cloud computing does is, it gives you these services on pay as you go model or on metered usage model. Now, what do I mean by a metered usage model? Now, when I say metered usage, basically we are referring to the fact that you'd be using these resources in particular amounts and for particular duration, and then the cloud will charge you for that duration. So if you talk about cloud computing, you can think of it as a very big space, right, which exists somewhere where you can put forth your data, you can put forth your applications, and they'll provide you with the storage, computation, security, virtual networks, and all that you need. So you can sit at your home or in your company and basically access all your data online by using web services or mobile services, right? So that is what cloud computing does for you. And when I say they let you use these on rental basis, now if you talk about something like Google Cloud Platform, these people have huge set of infrastructures that is already set. What they say is, you can come and use our space, our computation, our storage. The fact that we already have all this set up, you don't have to buy it. We'll let you rent it. So you can save a lot of money. You can use it for a duration that you want to, and then you can let go of it, right? So that is why it is a lot more beneficial than setting up your own servers. The fact that you're renting it and the setup is already in place, it is easier to scale up and scale down. And since a cloud platform is taking care of all the managing and monitoring of your services, your issue of looking into this data, looking into servers and all those things is sorted as well. As we go ahead, we'll be discussing these things in a lot more detail. But for now, I believe the gist is clear to you people. Just to simplify things for you, it is similar to consuming electricity. What we do with electricity is we basically have certain suppliers supplying electricity to us. We consume it for a particular duration. And once that electricity, at the end of the month, when we know that we've consumed these many units, our electricity board sends us a bill saying that, okay, this is what you need to pay because these are the amount of units that you've consumed. So what cloud computing does is it basically provides you services in these manner and also takes care of all the maintenance and other things that are associated with your cloud hosting requirements. So that is what cloud computing is in a nutshell, and thus it solves all the major problems that you've discussed. We've not discussed the database and security part. We'll do that as we go ahead. But for now, I believe the remaining points are clear to you. You can access the data remotely or by using your online services. Your costs are reduced because you're paying on metered usage, right? Dynamically, these servers can scale up and also scale down. And the amount of computation that you can choose and chop from, you have faster and better computation to meet your needs. So that is what cloud computing does in a nutshell. Let's now go ahead and see what else do we have here. So I think we have the definition here. Let's see whatever we just discussed. Does this definition do justice to that, right? Or our explanation does justice to the definition that we see on the screen. Cloud computing is the on-demand delivery of compute power, database, storage, applications, and other IT services or resources through a cloud service platform, or as we call it, cloud service provider, right? Via the internet on pay-as-you-go pricing. It is the use of remote servers on the internet to store, manage, process data rather than using a local server or your personal computer to do the same for you. So I believe by now, the gist is clear to you people as to what cloud computing is and what all can we achieve by using cloud computing. Let us now go ahead and take a look at what else do we have to cover here. So first and foremost, let's try and understand cloud service models. Now, this is one of the key pointers. For people who know cloud computing, this could be little repetitive, but the reason or the fact that we have many people attending this session who could be new to cloud computing, for them this is very important. The thing is, when you talk about cloud computing, these are more of the pillars, or these are the ways in which these different cloud service providers provide services to their users or consumers. So let us now go ahead and understand these cloud service models before we jump into GCP and understand what GCP is and what all it can do. Okay, so let's try and understand what do these cloud service models mean. Now, when you talk about service models, basically what they're trying to symbolize or basically represent is the fact that every cloud service vendor, in this case, something like GCP, Azure, or AWS, these are all cloud service providers, right? So when you talk about these cloud service providers, they have a particular way in which they provide these services to the users. So as a user, there are certain requirements that you may have, right? There could be certain users who say that what I want is I want a basic infrastructure, right? Where you help me plan or set up my networking, my storage, my server and virtualization requirements, right? That is, you give me the basic hardware or the bottom line that I need, right? You give me everything related to networking. How do I store my data? You take care of the servers that are there and also manage the virtualization. Okay, we'll understand what virtualization is. Or just to give you a gist, basically virtualization is nothing but it is an ability to set up multiple images or a feel of multiple devices on a single setup. Something like that. Say for example, running 2 operating systems on a single base system. That is what virtualization is. So you get a feel of running both the systems parallelly. So that is what virtualization does. So what certain customers might want is they might want their vendors to take care of these things. And what they say is, in turn, I want to control, like I want to decide what kind of operating machine or operating system I want to run on top of my hardware, right? Similarly, what middleware I want to use through which my OS can communicate with my applications, right? And then I can create my own applications there, put my data there and start running my business, right? This kind of an architecture or a service model is called as infrastructure as a service, right? So here, the basic infrastructure as a user is given to you on a platter, and you decide what kind of applications, middleware, runtime, operating systems you want to use on top of it, right? Similarly, the other approach that you see here is PaaS or platform as a service. So by the name, it is clear by now that here the entire platform is provided to you, right? The basic 4 pointers that we covered, like the networking, the storage, servers, virtualization is taken care as it is done in the infrastructure as a service module, right? But what it also helps you, or what the vendor also manages here, is operating system, your middleware, your runtime. What you only manage here is the data and applications. Now you might wonder, why would people have such requirements, right? Let's assume that I have an application in place. If you talk about businesses, say for example, big businesses where there's so many applications, so many things happening, right? Billions of requests being processed, number of applications running for each request, right? So in that case, do you have the time to set up everything? No. What do? Is you just have an application and you have your data and you want to run it as per your terms. So you say that you control all these things. So what a platform like Google will do is they'll basically just go ahead and configure everything for you. All they'll ask is what kind of application you want to run. Okay, so accordingly, this is the basic setup that you need, and they'll set up everything that you need. So you just put your applications or build your applications there and put your data on top of it. So that is what platform as a service is. And then finally, you have software as a service. Now, when you talk about software as a service, this is where everything is taken care by the vendor. All you do is you just consume the data, right? Let me give an example for these things to you people. Let's assume that if you talk about a cloud platform like AWS or GCP, where you can launch virtual machines. In those virtual machines, the basic setup is done by the vendor. All the operating systems, choosing what kind of virtual machine you want and all those things is taken care by you. So it's an example of infrastructure as a service. PaaS. Now when you talk about platform like Google Cloud Platform, right? Again, it provides you something like compute engine, or rather you have your application engine, not the compute engine. You have your application engine or app engine where the entire application is set up for you. All you do is you can choose what code, GitHub repository you want to import. Similarly, when you talk about AWS, you have something called as Elastic Beanstalk, which works on similar lines. And lastly, if you talk about SaaS, this is a cloud offering that is directly consumed by users. Gmail is a very good example here. In Gmail, you just open the web app, type your email and send it. You do not worry about how the application is being managed, who is managing it, what operating system it runs on and stuff like that. Your only concern is consuming that little bit of data that you want to, right? So that is what software as a service is, right? To give you another analogy here, I know it's getting stretched, but I believe this is a very important concept. So let's do that. Now, if you talk about another example, let's assume that pizza consumption is our example or our concern in this case. Now, when you talk about pizza, if you want to make it, right, what you'll do is you'll buy everything, your dough, basically all the stuff that you need, right? Your toppings and all those things. You'll go home, you'll use your own stuff that is there, right? You have your basic infrastructure in place, your gas, all those things, or cylinder, whatever it is. You'll cook your pizza on top of it, your oven, whatever it is, you'll cook your pizza there, right? And then you'll use your own utensils and consume it, right? This is something like IaaS. PaaS. PaaS is like ordering your food, right? So somebody else will prepare pizza for you. They'll just send it to you. You'll just bring it home, right? Use your plates and stuff, put it there and start eating it. Something like your PaaS, okay? And when you talk about SaaS, it's more of going out and eating. You'll just visit that place and everything else is served to you on your platter, right? The plates are theirs, the food is there, cooking is there, service is theirs. All you do is you consume it, right? So that is what software as a service is. So I believe the analogy is clear to you people and you have a better understanding of what cloud service providers are. So yep, by now we've known what cloud computing is, why do we need it? And we've also understood what are different cloud service models. Let's now go ahead and talk about some other bits. So when you talk about cloud computing, right, this is not a monopolist or monopoly based market. We have various cloud service providers that are there in the market that provide services in different domains, right? You have something like Amazon Web Services, Microsoft Azure, which hold a very large market share in the public cloud. Now, we've not discussed what deployment models are. but with time I'll throw some light on that as well. So when you talk about a public cloud, basically everything lies on a public server where other companies can also put forth their data. So when you talk about Google, Amazon, Microsoft, these are public clouds. So if you talk about public cloud market, Amazon and Microsoft Azure have a bigger market share, started way early in the market, one of the initial starters, and hence they have a bigger cloud market. Then you have something like VMware, Rackspace, DigitalOcean, Giant. IBM again is one more popular cloud platform, and Terramark. So these are some of the popular cloud service providers, cloud platforms that provide cloud computing services in different manners. So what we are going to talk about in today's session is Google Cloud Platform, which again is one of the leading ones. And we'll try and understand what makes Google so special and what are the kinds of services it offers. So let's just go ahead and take a look at those. So let's try and understand GCP. First and foremost, let's try and understand why GCP. So as you can see on the screen, what it says is Google Cloud Platform is a suite of cloud computing services that runs on the same infrastructure that Google uses internally for its end user products. It can be your Google search engine, right? Your Gmail, Google Photos, and YouTube. Now, you might wonder as in why do these pointers come in? Why GCP? This is simply to tell you as in how good a platform Google Cloud Platform can be, right? Now, when you talk about the fact that it uses similar space that these platforms that you see on your screen use, that should give you an idea as to how good a platform it is. Because when you talk about something like Gmail, YouTube, I mean, it's difficult to imagine how many people use YouTube every day, right? This is not something that is limited to India, to Asia, or to America, right? Be it any country, whether you talk about UK, whether you talk about Europe, right, the Australian continent, everybody's moved to YouTube these days, and not just watching content, also creating content. Forget out the fact that what rate it is getting consumed. Just talk about how many people are wanting to make a career in this domain. So that gives you a gist as to what we are talking about. And the fact that so many people are consuming so much data on a regular basis. Just to give you an example, I mean, I am someone who was an avid reader once. I myself spend a lot of time on YouTube these days. And given the fact that I work like good 9-10 hours a day, I still find like hour and a half every day to spend on YouTube. So that tells you, as in, this could be a personal opinion, but I am sure that many out there are consuming YouTube at this rate or even at a faster rate or at a greater rate than I'm doing it. Okay. Apart from that, whether you talk about Gmail, right, talk about Google Docs, Sheet, right, it's very hard to imagine a day where you do not open your Google Suite or Google Suite rather for basically going ahead and consuming either a doc, an Excel file or something like that. This again tells you how many people use it. This is all official talk that we are doing. Let's assume Google Maps, right? Google Photos, where all our phones back up our data mostly, right? Similarly, Maps. So what this tells is the amount of data that these people deal with is very huge. And the fact that Google or these things work seamlessly, I mean, it is very rare to see that YouTube has a breakage or basically YouTube server is down. We don't see that, right? So that tells you that the efficiency with which these platforms are handled and maintained, and where are these things put forth, where are these things handled and maintained, they happen on Google Cloud Platform. And that is why we see that Google Cloud Platform is one of the best in the market. There are many other reasons. We'll discuss that when we talk about the benefits part, but that's for the further slides. What we also see is some of the benefits that it provides. Let me just open these for you and then we'll discuss them one by one. Okay. It's very cost effective. When you talk about Google Cloud Platform, it is one of the cheapest cloud service providers in the market. And when you talk about GCP, what it does is it gives you per second billing as well. In many cases, if you are using a particular service for few seconds, it will charge you only for those limited amount of seconds. That is how good a service GCP is. Now, again, this is not the only benefit that it gives you per second billing, right? So if you've used a service for like 30 seconds, it will charge you for 30 seconds, 35 seconds, 37 seconds, whatever you consumed it for. But apart from that, what it also does is it gives you benefits where you can actually go ahead and pre-book your servers, your storage, right? And accordingly, depending upon the kind of subscriptions and plans you take, which are plenty to be honest, the service becomes very cheap, very affordable. One of the reasons is Google does a lot of research in ensuring that there's a lesser power consumption when you consume your data here, right? So it also ends up saving a lot of money there, ensuring the services are cheap to you people, and at the same time ensuring that the environment is not harmed badly. What they also do is they ensure that it is very scalable. Within mere seconds, you can scale up a device or even scale down. Not in all cases it would be mere seconds, but in many cases you can do that. So let's assume that you face a scenario that we discussed a while back. You have your website which is very popular, right? And in a peak time, you come across an issue where you need to scale up or just scale down in case of adversity. With something like Google Cloud Platform, that can happen in minutes and you won't lose your business. Apart from that, custom machine types. Now, again, we'll discuss this as we get into the practical part of things where I'll show you what do I mean by custom machine types. Okay, so stay tuned for that. But just to give you a gist, it gives you an option of choosing multiple machines, multiple services, where you have multiple options to choose from that meet a particular business need in your case. So if you have a particular requirement, you can specify that with the customization that you have. Now, apart from that, there are certain services that it provides in certain domains which are highly popular these days, right? Now, as you can see, there's Internet of Things, and also on the right-hand side, you'll see big data analytics, cloud AI, right? Serverless computing. Now, if you talk about IoT, big data, or cloud AI, now AI and big data is something that is very popular. And if you talk about last 5 years, there's everyone who's wanting to make a career in this domain. I've seen people from various backgrounds curious if they can actually go ahead and make a career here. And there are people who've actually been from other domains and who are distraught for the fact that they cannot actually move to that domain. So that tells you how popular these domains are. So what GCP does is, it is something that amalgamates everything that is there, right? It's not just about hosting applications, hosting servers, right? It gives you services that lets you process data on top of cloud. And this is where something like artificial intelligence and big data can be implemented on top of GCP or Google Cloud Platform. IoT, that is Internet of Things, which helps you connect various devices using internet, right? That actually helps you in data sharing, knowledge sharing, is something that can be simplified by using Google Cloud Platform again, right? API platforms and ecosystems. So what GCP does is it provides you APIs, which can basically help you tinker with the applications that you have, find different ways to communicate with the applications globally. And that is why it is so good. And serverless computing, something that we'll discuss as we move further. Now, when you talk about serverless computing, what serverless computing does is it basically helps you focus on your business where you do not have to worry about the servers. Basically, your service provider manages the servers end to end. All you do is you basically run certain set of scripts that are run only when an event is triggered, and then your server gets running, which you do not have to control, and your data is fetched, and the application then again halts until you make the next request. Now you'll understand why this is so important as we move further. But for now, this is what serverless computing is, where you get a feel as if there are no servers that actually exist. Okay, so these are some of the reasons, benefits as to why GCP is a very good or a popular platform that it is today, does reside to exist, right? So that is why GCP is very important and it finds its place amongst the top cloud service providers. Let's now go ahead and talk about the other pointers that we have on our plate. So what is GCP, right? So we've discussed certain set of pointers. GCP is something that supports those claims, right? Google Cloud Platform is a suite of cloud computing services and management tools offered by Google, right? Alongside a set of management tools, it provides series of modular cloud services, including your computing, data storage, data analytics, and machine learning. So guys, when you talk about these cloud service providers like AWS, GCP, Microsoft Azure, these provide plenty of services, almost close to 100 services when you talk about GCP. And if you talk about Azure and AWS, the services are more, but let's not discuss that. That's not the point of our discussion. So what GCP does is it classifies its services into certain domains, and then you can actually go ahead and choose and chop amongst these services, as in what do you want to use and how do you want to use it. We'll come to that when we get into the demo part and when we start discussing the different services that you saw in the agenda part. But again, let's wait for that to unfold. Meanwhile, let's just go ahead and take a look at the other pointers. Okay. By now, I believe the definition of GCP is clear to you people. It's nothing but an extension of cloud computing practices. We discussed what is cloud computing, and that is what GCP does. It helps you implement, or it is one of the service providers that lets you basically implement your application hosting management and all those things. Let's try and understand GCP a little more. So let's now go ahead and take a look at a use case, and let's see how Google Cloud Platform helps many customers across the globe. What we are going to do is we are going to take a look at a specific use case. So when you talk about this use case, Twitter, as we all know, is a highly popular tweeting platform, or rather social media platform would be a better word for this, right? So Twitter is not new to anyone. We all often read in news, right, that someone tweeted this, some paparazzi basically said this on Twitter. This is what the Twitter uproar has been about a particular case and stuff like that. So Twitter easily is one of those platforms where people share their opinions, right, to a very great extent, right? Why? Because it has a very huge customer base, just like Facebook, Instagram. If you talk about Twitter, it is one of those platforms where people put out their statuses, people talk to people put out their opinions, right? What this also means is this huge number of people who are actually on Twitter are also an audience for the company, that is for Twitter, right? So what Twitter does is Twitter also runs various ads, various campaigns on their platform, which many companies pay millions and billions for those particular ads, for those particular events. Now, if you talk about these ads and these events, as I've mentioned, the audience is huge here. The number of ads that are run are plenty. And when I say plenty, we are potentially talking about billions of engagement events that happen on Twitter. And when you talk about these billions of events, what these billions of events do is basically they affect hundreds of downstreams which different people use, right? If something is happening there, that event might be downstreamed somewhere else. Somebody else is showing it to somebody else, right? So the amount of people interacting here is huge. And not just that, when you talk about this platform, when these people interact, there's a lot of data that is being generated. Something that could be very important to Twitter and also to the customers that want these ads to be run, right? So what Twitter does is it has set up its own platform. Now this platform, basically what it does is it has various channel pipelines that collects data in various different metrics, and then they have various tools like your dashboards and stuff, right, which basically give these metrics to the concerned users or to the ad runners or customers rather. So Twitter's platform, that is SDFS, though great for upscaling and for handling data, there were a lot of issues, right? It was getting redundant in many ways where people, basically the company found it difficult to actually upscale. Apart from that, it was some of the legacy based software that people were forced to use here was again proving to be a pain point in terms of cost. Apart from that, migrating this entire infrastructure somewhere else was again an issue. Now, this is where Google Cloud Platform stood in. What Google Cloud Platform did was, first and foremost, it ensured that some of its storage features could move to cloud and not the entire thing. So handling the data became easier. Apart from that, in the second phase, what they also did was, this was starting 2017, right, when they did go ahead and put forth their first iteration where they solved some of the problems that I just discussed, right? Like ensuring that the data gets stored in cloud, and where people could use something like BigQuery or Cloud Bigtable, which again are services provided by GCP to process the data that is there. So the latency got reduced, and in real time, people could process these requests at a faster pace and with more reliability. The fact that the storage happened there, they were not initially forced to migrate the entire system to cloud, right? But partially move it to cloud. And as they moved ahead, they basically did go ahead and solve a lot of problems, right? What they did was they used built-in support by Beams. What it did was it basically helped solve clustering problem for GCP and for Twitter, where what they did was some of the operations could be performed at once and in large scale for multiple clusters. What they also did was they ensured that there was a deep integration of Google Cloud products, be it your Bigtable, BigQuery, PubSub, something like your Google Cloud's fully managed real-time messaging service as well. All these could integrate with Twitter's platform, right? And the programming model that was used by Beams, what it did was it unified batch and streaming data, or basically brought them together so that the processing again became easier. And by using this platform, Twitter rather got more efficient in basically processing these billions of ads, right? And now it can readily or more happily cater the needs of these billions of customers that they have, which are growing, and the platform that they have is going to support this upscaling part. So this was about the use case of Twitter ad management. Let us now go ahead and discuss some of the other pointers. Okay, so by now we've seen cloud computing, we've seen why GCP, what it is, and we've discussed one of the use case. The use case will start making a lot more sense to you when we discuss BigQuery, Bigtable, and all those things, which we will do as we move further. But before that, let's try and understand how Google operates. Not Google, Google is a wrong term to use here. How Google Cloud Platform specifically operates globally and what kind of infrastructure it boasts of. So global resources are multi-regional resources is what it has, be it your BigQuery, data store, cloud storage. Then you have your regional resources, right? App Engine instance, and you have your zonal resource like your VM instance and disk. Now, let me explain what these things are, okay? So basically when you talk about an infrastructure, what GCP does is it basically gives you zones, right? And regions. Now, when you talk about your zones are nothing but your servers that you put forth. To give you an example, let's assume that you have a server in a place called as, now I'm an Indian, so my examples could be little Indian, you might have noticed by now. Now, let's assume that Google has its server in Mumbai. Okay, let's assume that. So when you talk about the server being in Mumbai, what it does is, let's assume you are based in India and you want to run your business in India. So if you want to reduce some of the latency issues, or probably you want your data to be close to you, also you want to ensure that your government compliances allow you to run your business. And in that case, they want you to run the business in India. So in that case, having a server in India is good, right? So I want to put forth my data on Google Cloud Platform, but I want to put forth that data in India. So if there's a server in Mumbai, in that case, I can put my data in that server, right? So that server here is called as my disk, or basically my server, or my zonal resource. So Mumbai would be a zone for me, right? Now, when you talk about something like your server, that server has to reside in a particular region. Now, in that case, that geographical location is called as your region. Okay. So basically, you'll have your servers and you'll have your regions, and your data would reside in these different geographical locations. Now, these different regions across the globe are connected by low latency network. What that means is you can basically access all this data by using your internet and stay connected to these different regions and different zones. Let's try and understand them a little better. What I'll do is I'll just go ahead and switch into the web page where we can discuss the global infrastructure of Google Cloud Platform, that is. So when you talk about the Google's infrastructure, right, you can see some information here while it loads. It says that it spans in 22 regions, 67 zones, and 140 points of presence. It has 96 CDN edge locations. I'll tell you what edge locations are, and that is what it offers. Now, meanwhile, this loads up. Let's quickly see what CDNs are. These are nothing but content delivery network. Now, there's a networking service called as CDN. We'll talk about that. But what it does is, I mentioned the fact that when you talk about these cloud platforms, basically these are globally residing. So let's assume that I put forth my data in India and my business is in India. But there are customers who are accessing this data outside India. So for them to put forth a web request where they search for a particular data, if the server has to come back to India, fetch the information, again send it back to the user, it could take time. What if I have a pseudo server that is close to that particular user, and whenever a user makes a request, a copy of that data is maintained, which is more frequently accessed, right? So anybody who throws in a request to that data, it can be fetched from that server there and there, right? So this location is called as edge location, and the edge location is nothing but something that is provided by your CDN, that is content delivery network. So it is the job of this particular service to ensure that it helps communicate between these various endpointer requirements. Let's see what Start Exploring has to offer to us. There you go. So this has been updated. Last time I checked it, it wasn't like this. But last time when I checked, it was way back. So I think it must be a while that this has changed. So these are the different locations in which you have your data center. So I called about Mumbai, so I don't need to say that suppose in Mumbai. We can be certain that there's a region in Mumbai. Okay. So these are the different global regions where you have your data centers. Okay, dear audience, I'm not sure whether you can hear this music or not. It is the Google Cloud Platform playing this music. So I believe the gist is clear to you people, right? If you click on these icons, you'll get information about how this network is connected, right? And then you can explore it. So what are the CDN POPs, right? So Los Angeles can connect to these networks, right? Or these CDN POPs. So I'm going to close this because it's not good for viewing when the noise comes in. So as you saw on the previous screen, right, that is what the infrastructure of GCP looked like. Okay. So I believe the basic idea is clear to you people. We'll understand these services and these edge locations and all those things would be clear to you. When you talk about AWS and Azure, they too have a similar approach where they have availability zones and regions. Availability zones in their case are nothing but their data centers, and their regions are nothing but their geographical locations. So if Mumbai is a region, they'll have a zonal resource there or an availability zone. So they work on similar platform, and this is how the infrastructure of Google works like, or Google Cloud Platform rather, where you have your zonal resources or availability zones which are put forth in a region, and all these are connected by low latency network for fast data transfer and communication. So this is what the global infrastructure is. Let's now go ahead and discuss some of the other pointers. Now, when I say the other pointers, let's try and understand GCP service domains. Now, when you talk about GCP service domains, there are a plenty of service domains that GCP has to offer. The reason for that is there's so many services that GCP offers. Now, each of these are the major domains that GCP operates in. And when I say major domains, all of these domains will have sub-services or services that fall under these domains. Say, for example, when you talk about compute, now there are different compute services which are IaaS in nature, PaaS in nature, even serverless in nature, right? Similarly, you have storages and database. Now, this is where you can store your data, right? When you talk about storage, this is where you store your data in different files, formats, right? And database is something that lets you work with this data. Networking. Now, when you talk about a cloud platform like Google Cloud Platform, what it does is it has its resources that are spawning in different or existing in different parts of the world. Now assume that you want to host applications, right? So we are not just dealing with computation, storage, database. There could be a number of services that are intertwined. So where is the data coming from? What is the amount in which it is coming? What are the metrics that I need to track? This is something that your management tools tell you. And data transfer is something that lets these applications communicate with each other. So these are some of the core domains when you talk about GCP. Now there are more, but these are the core ones. So if you want to be a good developer, maybe a good architect, and even a good administrator, these are some of the core services that would be core for any GCP exam that you give. So it is important you understand majority of these services. So I believe the overview of these services is clear to you people. Let's now quickly go ahead and take a look at the first domain, that is the compute domain. So these are some of the popular compute services that GCP has to offer. Now there are more than these, but these are the important ones. Let's try and understand them one by one. Now the first on our list is the compute engine, which is more of an IaaS service. Now this is where the service models that we discussed would add more value to your exploration. So when you talk about the compute engine, basically it is an IaaS offering, as I've already mentioned. And what basically you can do is you can launch or spawn your virtual machines. Now, in case if you need a CentOS operating system virtual machine, or basically you need your Linux operating system or Windows operating system, you can basically go ahead and launch those services by a mere click. Okay. So not by a single click, but few clicks is what will let you have those engines up and running. Apart from that, you have your app engine. Now, this is where your platform as a service application comes into picture. I discussed Elastic Beanstalk as well, right? So you can basically go ahead and do that as well here. You will be provided with a platform. You can decide what kind of platform you want there, right? You can choose whether you want it, you want a Python based, right? You want some PHP based, you can decide that. What GCP will do is by using Compute Engine, it will launch a virtual machine by itself. You can just go ahead and put forth your data and application on top of it. Everything else would be managed by your app engine. Then you have your container engine. Now container engine, it is also known as your Google Kubernetes service. Now when you talk about Kubernetes, it is a container management service. Basically what Kubernetes does is it lets you launch these containers in which you can basically put forth your data, your bin files and all those things, and it will start running. You just pick up that container and put it on any base and it will start working for you. Let's assume that you have a multi-purpose charger, right? Where your phone gets connected once it does, and in front you have 10 different ports, and you can connect that to any kind of socket that is there, right? So that is what a container is. It will basically take in your data. In your case, if you're charging your phone, right, your phone is your data. So it will take that data, it will connect it or put it in that container, and that container can be used anywhere on any kind of platform or base basically. So that is what container engine does, and container registry is one of the services that lets you do that or supports that activity. And then you have your cloud functions. Now this is your serverless offering that GCP has to give to you. So this is what some of the popular compute services that GCP has to offer are. Let's now go ahead and get into the demo part. We've been talking for an hour almost. So let's just go ahead and see how the GCP Compute Services pan out, how they work. Okay, so what I've done is I've actually gone ahead and signed into my Google Cloud Platform account. Now, when you talk about your Google Cloud Platform account, what GCP does is it basically offers a free tier version to you, which you can use, and you can practice quite a few things by using this free tier account. So when you have a free tier account, it comes up with a certain set of benefits, like all the basic services can be implemented there. And what GCP does is for a certain duration, it provides n number of units of money for you to use. So you can use that free units or those free units to spawn your instances, launch your storage services, database services, and stuff like that. So what you have to do is you have to just go to Google Cloud Platform free tier, create an account. They'll ask for your credit card. That is for verification. In case if you're using paid services, they'll charge you, but they give you a list of free services, so you can always use those free services, right? So once you do that, once you give in your credit card details, they'll verify your account and you'll be having an account that is ready to use for you. So ensure you go ahead and create a free tier account for your usage. Okay. Once that is done, you can always come to this platform and start using it. You can see that all the major services, be it your IAM, APIs, compliance, security, all these services are here. Okay. We'll be discussing these one by one. Do not worry about that. But meanwhile, let me just scroll down. The compute engine is the one that we'll look into right now. App engine is your service where you have your PaaS offerings. We'll see the IaaS one, right? The basic one. In your compute engine, you have your services, versions, instances. So a virtual machine is called as an instance when you talk about these cloud platforms. Let's open one of those. Unable to find a resource you requested. There was an error loading it. So let's reload it. Okay, no problem. We'll go back and we'll try something else. So let me go back. Let me just click on it and let me just go to compute engine. This was the reason, because I probably did it from the wrong place. So you can go for virtual machines, VM instances, right? Let's click on VM instances. So there's an instance that I created a while back. This was just for the usage purpose I wanted to show you, but let's not do that. Let's just stop this first. Now it might take a couple of minutes for this to stop, but I can instead just say delete. So let me delete it. Are you sure you want to delete it? Yes, I'm very sure I want to delete it. So it should delete this instance, and once this instance is deleted, I'll be having this interface for my usage. Okay. And there are various other options that you can do. You can see at the panel at the top where there are quite a few things that you can basically control. But meanwhile, let me just delete this instance and we'll launch a newer instance. Okay. So let me just refresh this and see how it pans out. If it is still deleting it, then it could take a minute. Okay, let's just say create now. During the course of this video, I'll also show you how do these things work in other platforms as well. I'm not going to walk you through them in detail rather, but I'll just give you an idea as to how these works. or those services also work there. So let's quickly take a look at, or just add a name here for our instance that we are planning to launch. Let's call it SAM4321. Labels, do you want to add a label? Because if you create multiple instances with similar names, it could be confusing. So you can add a label as to what that instance is for. You can see that I have this much amount of free credit, somewhere around 21,000 Indian rupees for my usage. So I can span these many instances. If I use this particular instance for a month long, it would charge me $25. In Indian currency, if we say like 70 to 75 rupees for a dollar, right? That is 750 for 10. So around roughly 2,000 rupees for an instance to run for the entire month if I keep it running, which you might not need to, but giving you an estimate, right? So it gives you the detailed information as to how long would this instance be running and how it would be working and stuff like that. Okay, let us now go ahead and discuss some of the other pointers. So it is a general purpose instance, right? If you can click on these things, you'll understand quite a few other things, right? So basically, when you say a general purpose instance, it serves a moderate performance of your computation and storage. Okay. If you talk about compute optimized, those are optimized for your computation, and memory optimized are something that give you higher memory or better memory usage. GPU is something that is used for your graphical processing. Okay. So we'll stick to the general purpose for now. This is its configuration. Okay. You can choose what you want to. You can also use a micro one. Okay. So this is not a concern for us. We are using it for a demo purpose. You see, each time you select one, it will give you all the details. It is using 2 virtual CPUs and 1 gigabyte of memory. And I can choose what kind of machine that I want to use here. If I click here, I'll get to choose. So I can use a Debian, right? I can use a GNU Linux. So instead of Debian, I can go for Windows and other things as well. So I have the option of choosing other servers if I want to, whether it's a Linux one, Red Hat one, and stuff like that. Let's stick to CentOS for now, or the Debian one for now. Okay. Buster size is balanced. If I go for standard, and if I say apply, now if you scroll up, you'll see that how much this one costs. So it will cost me $6 monthly. So it is fairly low, right? So from $25, we've come down to $6. Why? Because we've launched us or planning to launch a smaller instance. So these are the things that we can configure. If you go ahead, you have other things to configure as well. Okay, or you can stick to the basic ones if you want to. Let's just go ahead and say create one. And just like that, my instance would be created. Guys, here you also have an option of working on quite a few other factors, right? You can just go back to the instance and see what kind of virtual network it falls under, what kind of storage that is attached to it. By default, you'll have persistent disks attached to every VM that you launch. We'll see what do those mean as we go ahead. But just to give you a gist, that is what it is. Yeah, so it is giving me a notification. This I can dismiss because I'm going to delete this instance any which way once its usage is done. So if I select this, why am I getting this thing here? I don't want it. I'm just going to scroll it for now. And it gives me different ways to connect. I can use SSH to connect to it. I can use it in different browser as well. Open browser windows with private SSH key and use this command. So this is the easiest way. Let's do that. Let's select this, copy it, and I'm going to say run in Google Cloud Shell. And within a minute, my instance would be up and running and I should be able to connect to it. There you go. It has fired up my terminal, right? And using the terminal, it has put forth that command as well, using which I can connect to the instance. If I just hit the enter button, do you want to authorize? Yep. And just like that, it would help me connect to my instance. You see? So it has connected to the instance that was there. And I can actually go ahead and start using this Debian if I want to. Similarly, if you go back to AWS, right? There's a service called as EC2 that lets you do the virtual machine job. And you can see that there are instances that you can create and launch. You can always come here and say launch instances where you can choose different kind of instances that you want to. Okay. It will also give you details about what instances are up and running and what are you planning to do with these instances and stuff like that. Okay. So there are quite a few things that can be done here, and you can use this AWS platform for similar things as well. If you close it, if you go back to AWS services, it also has plenty of services that you can use. So we'll compare these services, how do they fare with each other and what kind of offerings these platforms give us. But by now, I believe the basic compute service is clear to you people, how it works and what all can be done with it. Okay, let's go back to our presentation and see what are the other pointers that we have to cover here. So we've seen how compute services work, at least the basic fundamentals as to how virtual machines on GCP work, and we've seen how, as they call it, compute engine rather, works on GCP, which is equivalent to AWS EC2. Let's now go ahead and discuss how storage services work on GCP. Now, when you talk about GCP storage services, there are plenty of storage services that are there on GCP. And the reason storage services are important is when you talk about cloud platforms, right? It is very difficult to imagine any cloud platform without data. And the reason is simple, right? I mean, any application you create, any kind of data you put forth, you are dealing with data, right? Be it monitoring the data, managing the data, analyzing the data, right? Processing the data, everything happens on cloud. And that is why when you talk about storage services, they're fairly important. Now, when you talk about these storage services, they will store data in different ways and in different formats, right? You could be required to store your images, you could be required to store your videos, you'd be required to store maybe your structured data and stuff like that, right? So first, here you have something called as cloud storage. Now, it is a unified cloud storage service. What this unified cloud storage service does is it lets you store data in the form of blobs, or you can store your data, be it your images, as I mentioned, be it your videos, right? Be it your other forms of data. It can be your structured data, unstructured data, right? So you can store that kind of data here. But mostly the data that is stored here is stored in the form of objects, or objects rather, and is stored in containers called as buckets. Now, when you talk about other cloud platforms, something like AWS, Microsoft Azure, now on these platforms, when you store this kind of data, you have separate services for storing the data. Now you have something like S3, right, which stores all these kinds of data. Then you have something called as EFS, which stores files in the form of data. You have EBS for block storage. Here to have persistent disks for that, but I believe you get the gist what I'm trying to say here. Apart from that, you have your other data services, like you have your big table, that is cloud big table, and your cloud data store. Now these are your NoSQL databases. Now when I say NoSQL databases, I'm talking about those databases that basically deal with not only SQL data, it can be your unstructured data as well. Now these are different from your cloud storage. The reason is these are more towards the line of database services where you can process your data, right? You'll be having your data stored in a particular server, and then you can process this data by using something like cloud big table or your cloud data store. When you talk about cloud data store, it mostly works with hierarchical data, whereas your big table is responsible for dealing with data that requires low latency, right? Quick processing of data. You can read, write your data, and it gives you highly, or you can say high throughput performance for data analytics as well. If you go ahead, you have your cloud SQL. Now this is something that deals with your SQL data, or your sequential data rather, right? So if you have structured data and you want to put it in databases and process it, this is where your cloud SQL storage will come into picture. And then you have something like persistent disk. Now what is a persistent disk? When you talk about persistent disks, we are talking about block storage. What is a block storage? This kind of storage always needs a host machine, a host system to access this kind of data, right? So when you talk about this kind of storage, to give you an example, let's assume that you have your hard disk, right? You can store your data in your hard disk, but how? You need to connect that hard disk to your system, right? To some other device where you can put forth that data and copy that data there, right? So it is dependent on the host machine. But your block storage again comes in two parts. You have your ephemeral storage and persistent storage. Ephemeral storage is something that dies with your instance. Okay, that means if there's a particular instance or virtual machine that you've launched, or a system you've launched, if you delete that particular virtual machine, your data would die with it. In case of persistent storage, there's a slight difference here. In your persistent storage, your data won't die. Why? Because you are creating this storage separately, and you can attach it to your instance, you can detach it to your instance, and it will not die even if your instance does. Okay, so this is what persistent storage, and these are what cloud storage services are like. I will understand these services practically as well, but before that, let's quickly jump into the other set of services, that is your networking services. Now, when you talk about cloud networking services, again, network is a very important aspect of cloud. I believe I've already discussed this when we talked about popular service domains on a surface level. And the reason for that is when you talk about clouds, as I've already mentioned, your data could be residing in different parts of the world, and there could be different things that you need to control. One of the major things that you need to have here is an umbrella of network that connects these different locations and places where your resources lie, right? So there would be a lot of things like who gets to access what, how, right? What are the firewalls that are in place? What are the subnets? What are the IP addresses? What needs to be assigned to whom, right? And this has to happen virtually because you cannot have physical subnets and networks, right? You cannot have physical routers and stuff. Yes, there would be some physical routers, but all this network is basically connected over a virtual umbrella. And that is why you need these virtual network services that GCP offers, in this case of Google Cloud Platform, right? So let's try and understand them, as in what are these and what all can you do with it. So first you have your virtual private cloud. So whatever I've just discussed, right? So you can create a virtual private cloud or cloud virtual network, right? Where you can put forth certain set of resources in that particular network. Say, for example, you have like 100 devices that you can assign in that particular network. So you can basically create subnets, create sections, decide how many IP addresses you want to assign to a particular network or to a subnetwork. Again, decide what resources fall under that particular network and what are the ways in which you can access the resources from there, right? So it's a mix of various IAM services as well, something that we'll discuss as we move further. But I believe by now the gist is clear to you as to what your virtual private cloud does, okay? Or your cloud virtual network. Apart from that, you have cloud load balancing. Now, this is another interesting service. We discussed about those applications where we have our e-commerce website and it experiences traffic. So if we stick to our Diwali example or a New Year's example, we are talking about a lot of people shopping, right? In that case, there could be a possibility that there's a lot of burden on a particular resource, a server. In that case, you have one option of scalability, which we talked, right? You can upscale horizontally and vertically as well. Now, for people who do not know what horizontal scaling and vertical scaling is, we are referring to two important pointers here. The first one is how do you scale horizontally? That means if there's a lot of load on a particular resource, you can have multiple servers attached, multiple machines attached. And there's something called as vertical scaling where you can actually go ahead and increase the computation storage power of a single machine. So there are different ways to scale as well. But what does load balancing do? What load balancing does is instead it diverts the traffic from a particular resource to the other to manage the load in case of existing infrastructure where you do not need to scale up or down. This is very good in terms of disaster recovery as well, where you do not have to worry about if a data center goes down or stuff like that. So say, for example, you have an instance where you have this your e-commerce website and it is experiencing a lot of traffic. Can you just transfer your traffic to some other node or some other instance or virtual machine that is located in some other region or which is close by? So your traffic would be distributed. Yes, absolutely. You can do that, and you can do that by using cloud load balancing. Okay. So these cloud load balancers, they come in various forms, right? And there are different purposes for these. There are application load balancers, there are standard load balancers and stuff like that. Okay. So depending upon the applications, they vary as well. To give you another layman example for these things, you have something, if you are in India again, then you'd know that the Cosmo cities here experience a lot of traffic. And if you stick to that traffic, you'll either get late to your work or you'll have to start a couple of hours early, right? So we always know our shortcuts where to move from to do what, right? So if there's a lot of load, lot of traffic in particular area, you can always take this other route. And that is what cloud load balancing does in terms of your data, right? Where should they move your data? They'll move it to some other load balancer where it can be balanced better. Okay. Moving on, you have your cloud, or rather you can say content delivery network. Okay. So cloud CDN or content delivery network is again a content distribution service. Okay. So I'll tell you what this does for you. Let's assume I'm again going to stick to an Indian example. Now in India, we have cities like Mumbai, you have your Bangalore, you have Ahmedabad, right? You have Kanyakumari. The reason I'm specifying these cities are, let's assume that I'm based in Mumbai right now and I want to move to Ahmedabad, which is in Gujarat, or to Bangalore in Karnataka, or Kanyakumari down south, okay, right to the bottom of the country. So depending upon their locations, the closest to me would be Ahmedabad from Mumbai, right? The next would be Bangalore and the last would be Kanyakumari because the distance is lot. Let's assume that Mumbai is a server. Or for example, let's continue with this example. Let's assume that I want to travel to these places and I use a similar vehicle. Let's assume I'm either taking a bus or I'm taking my personal car, right? So if it takes like what 10 hours to reach to Ahmedabad, it would take like around 15 to 20 hours to reach to Bangalore and somewhere around 25 to 30 hours to reach to Kanyakumari, depending upon how I leave from Mumbai. Okay. So the point I'm trying to make here is the more the distance, the difficult it is, or the longer it will take for me to reach to a particular location. So if Mumbai had a server and I had to fetch data from Mumbai server and I was based in these three different locations, the earliest I would get the data would be in Ahmedabad and the latest I would get it is would be in Kanyakumari, right? So what that implies is data latency can be a big issue. So how does Google Cloud Platform solve this issue? It creates content delivery networks. Or in simple words, it has edge locations. So each edge location is located close to a particular data center. What they do is they fetch the frequently accessed data from the server and cache it there in that particular edge location. So that way, whenever if I am trying to access this data, let's assume from Kanyakumari, and if it has been cached there, I would be accessing this data at a faster rate because the distance would be minimized, thus resulting in low latency results. So this is what content delivery network does. And then you have your cloud domain name service. Now for people who do not know what domain name service is, let's assume that we all use website like Amazon, right? Or maybe our Google search engine. So we put in an address there, right? The address can be something like www.amazon.com, right? So this is an address which is easier for you to understand in a layman language, right? Similar to if I have to visit to my friend's place, right? I'll be looking at the address that is given, maybe flat number X, road number X, area number X, and something like that, right? So what do these labels tell me is where does this person reside, and it is easier for me to find this person based on this address. Similarly, if you want to access particular set of data, you'd need to know where does this data reside, right? Your website address. And that is something is controlled or governed by a domain name services. Now with cloud, or in this case with GCP, you specifically have a service called as Google Cloud Domain Name Service, which basically lets you control these domain names, have access to data for people from different locations and stuff like that. So the domain naming service that is controlled by Google Cloud is Cloud DNS, which lets you do these domain naming service activities. Okay. So this is what GCP networking services are, and this is what these services do. Let us now go ahead and take a look at the demo part and explore some of these services a little more. Okay, so previously we saw how to create an instance, right? Now we'll go ahead and explore the storage service as well. So guys, note one thing. You might have not realized in the previous part that when we saw how to create an instance, the fact that whatever thing I'm creating, it goes in this my project, right? So it is a container where my GCP is storing all my resources, okay? So similarly to store your data, you also need to create a storage account, okay? So when you start this for the first time, if you click on cloud storage, it will ask you to create an account. So make sure you do that. You just have to enter a name for it. And I think you should be good to go ahead with it. Right now, in my case, I think I should be having a storage account already. So I'm going to just go ahead and say cloud storage. And once you do that, no sooner this page loads, this is where you get a notification. When you click on create bucket, it says that you cannot do that right away. Now, again, as I've already mentioned, bucket is nothing but a container where you store your objects or your files, right? The data that you plan to store. So you have to create a bucket first. So when you create a bucket, guys, please note this thing that these buckets have unique names. You cannot just go ahead and say that, okay, use this bucket in this form. Okay, you'll have to give a specific name to it. And if the name is already been taken, you will not be able to create that bucket. So let's try and create one. There are other clauses as well. If I'm not wrong, you cannot use a caps name as well, something like that. But let's try it if that works. So I'm going to name it GCP demo bucket. I'm going to say continue. It says that use only lower cases. As I've already mentioned, there's an error here. So let's say GCP demo bucket and say continue. This bucket name already exists. As I've told you, the bucket has to be globally unique. Let's give it a terrible name for now. This I'm sure should be acceptable. So guys, once we click on continue, these are the other things that we need to take a look at or need to understand, as in what kind of bucket I want. Do you want it regional, dual regional, or multi-regional? By the name itself, it should be clear, as in the latency is reduced because in a regional bucket, you are dealing with a single region, single bucket. All your work would be concentrated there. In dual region, you'll be having high availability, low latency, and you can access this data across two regions. In multi-regions, you can have data in multiple regions as well, or buckets in multiple regions as well. That is, you can access this bucket from multiple regions. In this case, we are sticking to the region one. This is a basic demo. Apart from that, you can choose what kind of region do you want to store or create your bucket in. Say, for example, I can select Mumbai, India, right? Let the basic one be here. This is not very important for us. So I'm just going to go ahead and say continue. Okay. And once I click on continue, the next thing is I need to choose what kind of storage account I want to use right here. So I have certain options here, whether I want a standard storage, nearline one, cold line one, or archive one. You might read what is written here. Meanwhile, I'll explain what those are. Say, for example, you want to store your data, right? It is mission critical data and you want to access it right away. Okay. So in that case, you should store your data in standard access. This is where no matter when you put your data, you can retrieve it right away. Okay. No retrieval time is required. Nearline is something when you put your data there, you have to put that data there for at least a month. You cannot access it or retrieve it before that. In some cases, you might want to store your data for a longer duration, maybe around a quarter or 3 months, as we say. That is where you can use your cold line data. And finally, you have your archival data, which is for a duration which is longer than 1 year. Now you might wonder as in why do we have these kind of different brackets? First of all, the first one is the costliest here. Why? Because there's no retrieval time. I mean, you do not have to wait for more than seconds, right? The latency is like in seconds, so that which is very less, even milliseconds in some cases, so which is very less. So since if you're talking about mission critical data, it is always wise to put your data in these kind of storages or in the storage. Next is your nearline and the others. Now, what do these others imply is there could be a particular requirement for you to store your data for a particular duration. Suppose that you either might not want it or might not want to use it, right? Say, for example, there's a particular data that you don't want to use, like is something that you're certain you will not use for years. Medical records could be one example, or something like your school leaving certificate. So let's assume that I go to my school and I collect a copy of my school leaving certificate. Okay. Say, for example, take my case, I passed out in 2007, my schooling. Okay. So if I am to take a look at this information, right, and this for some reason for today, it's like 2021, right? So like 14 years, I want that copy of my school certificate. So I can always visit my school and apply for that, right? But the fact is I'm accessing this data like what after 14 years, right? So this data is important to me, but not something that I need it right away for mission critical purposes, right? So what happens is I go ahead and request them for that birth certificate, and they might say that, okay, come back after 2 days, right? Because we'll have to go through so many records to fetch your data and something that you've not accessed in like 13 years. So something like archival storage is similar to that, where you do not need to access your data regularly, but you need a copy of it to be maintained somewhere. So you can do that. Since the retrieval time is longer, it's cheaper compared to other storages. And why do you store data in these kind of things, right? Let's assume that Edureka makes courses, right? What if Edureka had its database on something like GCP, right? In that case, if I had to store a particular copy of my course, which I do not use regularly, I might put that copy in a cold storage or archival storage, which I do not access frequently, right? So the data would be there, but it would not cost me a lot. But what if there's a course that I do not access at all and I put it in standard storage? Now it is being charged very heavily. I'm being charged very heavily for that, but it's of no use, right? So that is what these different storage systems talk about. Okay, I hope that is clear to you. Let's continue with the standard one because this is a very minor demo that we are creating. What kind of access you want, fine grained or stuff, let's not get into details of that. It's not important. Let's just create a bucket. And just like that, I'm sure a bucket would be ready. You see, within a minute you have, not even a minute, within click you have the buckets with you. It says upload file. I'm just gonna go ahead and say live stats and I'm gonna open that bucket. And there you go, the live stats PNG file is uploaded. So you can upload your videos here, you can do quite a few other things here. Now again, you might wonder as in, is this the most efficient way to use this particular set of data? Are there other things that I can do with it, right? Yes, there are a lot of things that you can do. You can basically go ahead and assign bucket policies, right? As in you can decide who gets to access this file. Say for example, this is a private bucket. So storage is standard here and you can see public access, it's not public. So not anybody can access this data but me, right? And it says retention expiration date. There's no date here. Why is that? Because I haven't set a life cycle policy. Something that I can do when I say assign a life cycle policy, what that means is basically I can decide after a particular duration what to do with this file. Now there's a certain set of data that might be useful to me in real time, but that data might not be as useful after 3 months, right? So let's assume that there's a particular image that I put forth here and I realize that after 3 months I'm not using that image. or I know that after 3 months I will not be using that image at all. So in that case, I can assign a life cycle policy to it. I can say that in that life cycle policy, I can say that, okay, for 3 months, let it be in standard storage. Post that, either move it to cold line or nearline, or directly move it to archival, because I might not be accessing that file for that longer duration any further. In case if I feel that I'm just not going to access that again, I can just set an expiry date and it would be deleted and garbage collected by GCP. Okay. So that is what your lifecycle policies let you do. The other things that you can do, you can delete your content here, download it, right? You can upload your files and do other things as well. So this is what your bucket or your Google Cloud Storage lets you do. Now with AWS, you have something like AWS S3 Simple Storage Service. I'll show you what that is, but when I discuss the IAM part, that is when I'll show you, because I want to also talk about multi-factor authentication and stuff like that. So meanwhile, you can wait for it. Okay. So this is what these buckets or these storage services do for you. So I hope this is clear to you. We also discussed the VPC part, right? So let's quickly see what VPC also does. So do we have VPC here? So for VPC, I'll have to maybe scroll up or scroll down. VPC, there you go. And you say create your VPC networks. Okay. So this is where you can create your virtual private cloud. By default, you can see that these are the subnets that are assigned to it. I will not create one, but I'll show you what can be done here. It's fairly easy. You can definitely try doing it on your own, but let's not spend too much time doing this. Okay. So you can basically give a name, maybe ABC as a network. Okay. That's a terrible name, but let's stick to that. Apart from that, you can decide whether you want to automatically create subnets or custom create it. What's the difference? When you custom create it, you specify what IDs, IP addresses do you want to put under a subnet. If you select automatic, it will automatically distribute the IP addresses. Say, for example, you have 20 IP addresses. You can decide what these 20 IP addresses need to be assigned to what subnet. Okay. So accordingly, you can decide that based upon the region in which these exist. Okay. So this is one. And then once you do that, you can also go ahead and create a firewall here. So what do we do with firewall? With firewall, you can decide who gets to access this network, right? Where are you allowing data to enter into this network? Now, let's assume that I have an instance. We saw how to create a CentOS instance, right? So if I have one lying in this network, in that case, I need to decide how can I sign into this instance, right? Am I SSHing into it? And does my virtual private cloud allow me to do that? So I can set up policies that let us control these things. Okay. So this is how the virtual private cloud works. And similarly, if you look for CDN, I'm sure you'll have that here as well, because we've discussed that. So you have your cloud CDN as well. So when you talk about your cloud CDN, you can add origin here. So when you say origin, you can decide where do you want to basically go ahead and cache your data from. That is why you add your origin and stuff here. Okay. So that is what your CDN lets you do. Okay. So this is what CDN is all about. Let's now go back to the presentation and discuss the other services that we have with us. So let's now go ahead and try and understand how GCP security works. Now, when you talk about security, security is a very important aspect for clouds as well. If you go back to like 2014, 2012, people already questioned cloud security. The reason was there were many outages back then where people lost a lot of data, but that has changed. Whether you talk about physical security, where these data centers are governed 24/7 by physical resources or physical individuals, also to the fact that where people do not know where these data centers are actually located to visit. Yes, we know there's a data center in Mumbai, but you will not know where it is located. Very few people know about it. Apart from that, if you talk about network security, there are various practices, be it your IAM, where you can control identity and access management, be it running security checks through and through, or be it setting up shared security models where you as a consumer get to control certain security activities, and cloud as a vendor knows that, okay, these are the things that we need to control, and they also control those security aspects. So you get more security when you talk about cloud. Now, what are the things or what are the services that are there? Now, when you talk about cloud security services, there are plenty of security services that are there in the market. The major ones are, you have your Google Resource Manager, then you have your IAM, Security Scanner, and Platform Security. The others as well, as I've mentioned, but these are the core ones. If you talk about the Cloud Resource Manager, what a Cloud Resource Manager does is it lets you set up a structure, right? We've talked about that your projects hold all your resources. So it's a similar structuring that we are talking about. Since you put all your resources in a structure, it becomes easier for you to decide who gets to access what, and more importantly, how. Okay. Now this is where your IAM also comes into picture. What IAM does is basically IAM ensures that you as a user gets to control who gets to access what and how. So we'll see this in the demo part. I basically have some IAM users through which I can access my AWS account, which is very similar in Google Cloud Platform as well. I'll show you how that works. Okay. So basically, when you talk about Cloud IAM, what it does is it helps you create users to start with. So I can create, say, for example, 10 users for 10 different people. So I have an organization where I want these 10 different people to do different things. So I'll be creating 10 different accounts so that when these people access the cloud, they get to access this cloud from their account, and I can decide how much access to give to which individual, right? I as an admin, I have entire control, but others I can decide who gets to access what, right? To give you another example, let's assume that you have a set of developers who might be needing access to all the developer tools and activities that concern it. Next is your analytics team who needs access to more management tools and not the developer tools. So I can set up two groups, right? I can create two groups. This is another concept where you can create groups. And in these groups, I can decide who gets to access what in that group and accordingly create users and put them in that user group. So basically they get to access only those resources first, right? Then you can create also policies where you can do some service related work where you can decide what service requests to throw and all those things. So that is where your policies and roles come into picture. So that is what Cloud IAM does. Basically, it lets you govern the identity and access management to your cloud platform. Then you have your Cloud Security Scanner. Now, what exactly is a Cloud Security Scanner? When you talk about a Cloud Security Scanner, basically let's assume that I have n number of virtual machines created. Now these virtual machines would be accessed through different URLs, right? The applications that are based on top of them would have certain URLs and people would be accessing it from different resources. What Cloud Scanner does is it basically scans or crawls through all the links, all the websites and applications that are being accessed and checks for security. When you talk about Google Cloud Platform security, on the other hand, it is a more generalized version which controls security on top of Google Cloud Platform. So this is what, or these are what the security services on Google Cloud Platform let you do, okay? And what they are exactly. Let's now go ahead and understand something else, and then we'll probably again jump back into the demo part. So you have the management and developer tools. Instead, what I will do, guys, is I'll just go ahead and discuss all these services at a stretch, and then we'll explore them in the practical part of things, okay? So let's try and understand the management and developer tools as well. Now, when you talk about the management and developer tools are something that let you govern all the management activities that are there on your cloud, right? So say, for example, you have your monitoring and logging services. So I don't know whether you checked it when I opened my GCP. There was a dashboard there. So it is something that can be created by using your monitoring and logging services. So I'll show you once we get into the demo part. So that is where you'll get data about all those logs, all the requests that you've made, right? All the services that you've launched and their CPU utilization and stuff like that. Apart from that, you have other services like your Cloud Shell, Cloud APIs, right? These let you control your applications more programmatically through command line interfaces where you can actually go ahead and code and then access these resources. Apart from that, you have your Cloud Console, which limits or reduces the amount of coding that you need to do in order to access these resources. And then you have your Cloud APIs, which basically, again, I believe I already discussed that, so let's not get into that. But APIs and CLIs, that is what they let you do, or Cloud Shell, that is what they let you do. Mobile Cloud App lets you basically monitor your data using your mobile applications that you can connect on your phone by using your Google Cloud. So your data would be residing on cloud, but you can monitor that data by using cloud mobile apps. And then you have your developer tools. Now, this is where your developers come into picture. When you talk about cloud, you are not going to just go ahead and put your data there and manage that data, right? You'd also be building applications that you want to use. So can you do that on top of cloud? Definitely you can do that on top of Google Cloud as well. You have something called as Google SDKs, then you have your deployment manager, and you have your Google Cloud source repositories. So SDKs is something that lets you control your software development toolkits on top of cloud, and deployment manager is something that lets you control your container applications on top of Google Cloud. In terms of cloud source repositories, it is something that basically lets you have a version control device on top of cloud. So we all have heard about Git, right? So Git is nothing but your version control device. So using GCP Cloud Source Repository, you can create a similar version control on top of cloud, or you can even connect to Git to basically import those repositories, and then you can pull, push your data and work on top of it. Okay. So that is what your Google Cloud Source Repository lets you do. Next, we have our cloud tools for Android Studio, where you can do Android development here, right? And then there are other application-based tools as well. Something for your PowerShell implementation. You have tools for Visual Studio and plugin for Eclipse and other test labs as well. So that is what your developer tools let you do. Okay. So this is how the development and management tools on cloud work. Let's now go ahead and discuss some of the other tools as well. Then you have your big data services on top of cloud. Now, what do your big data services on cloud do? Okay. So there are plenty of services here. You have your BigQuery, you have your Dataproc, PubSub, you have your Dataflow, Data Lab, Genomics, and a number of other services. Now, BigQuery is nothing but your data warehouse that basically lets you analyze your data and process data at a very low latency. Dataproc is again another service that lets you deal with your Apache server, Apache Hadoop kind of infrastructures. Now, when you talk about big data, right, we are talking about Hadoop infrastructure. This is where we are talking about unstructured data being handled. And one of the easiest way to put your data there is by using something like a Hadoop ecosystem and by using Spark that lets you stream process data at a very quick rate. So that is where your Dataproc service comes into picture. It basically lets you manage these kind of data on top of your cloud and basically lets you manage your big data activities on top of cloud. Then you have your PubSub and Dataflow. Now these are your streaming services. So if you've heard of something like Kafka, that lets you publish your data and basically lets you to subscribe to other topics as well. Say for example, you use Gmail, right? On Gmail, what we do, basically we have certain emails that we've subscribed to and we get them regularly, right? You can decide to unsubscribe as well. So when you talk about streaming data, if you want certain topics to be subscribed to, you can do that by using PubSub and Dataflow. So Dataflow does not let you subscribe, but it works on handling streaming data rather. And then you have your Genomics and Data Lab. Data Lab again is a tool that handles big data for you, and Genomics is something that lets you work with research kind of data. Now, what do I mean by research kind of data? Now I'm referring to that data that basically lets you deal with something like COVID that we had in 2019, right? Suppose that there were many people wanting to research on genomic data, the DNAs and stuff, right? To understand how did this virus evolve. So that kind of study falls under life sciences. And if you are a group of people who want to do it, you can do that on cloud. All your basic infrastructure and underlying aspects will be controlled by Google Cloud Platform. All you worry about is how do you work around that piece of data, that set of data. Moving on, you have something like your GCP machine learning services. Now, when you talk about GCP machine learning services, we are referring to practicing machine learning on top of GCP cloud. Now, machine learning, as we all know, has been trending a lot in last decade, and it will continue to trend because the importance of data has changed widely in recent times. And that is why we see people wanting to make a career in these domains. So can you do or perform data science activities and machine learning activities on top of Google Cloud? Definitely you can. How do you do that? You have these set of services to let you practice these things, right? So first and foremost, you have a cloud machine learning. So it is similar to AWS SageMaker, where you can actually go ahead and practice these things like building your Python, having a Python notebook configured readily on top of an instance, and then building a model. And with something like cloud machine learning, it becomes easier for you to deploy those models as well in the public environment or in the production environment rather. Then you have your APIs. Now these are cognitive services. What do I mean by APIs or these cognitive services? So let's assume that you want to process images. You want to understand what is this image specifying, right? Whether there's a person in it, there's a celebrity in it, does it match with other images and stuff like that? So you can use an API like Vision API. Speech API is something that lets you convert your text to speech, speech to text and stuff like that. Natural language APIs are something that let you work with your lexical data analysis or basically doing sentiment analysis and stuff like that. Then you have translation and job APIs as well that basically let you translate your data, and job APIs are something that again deal with data handling in general. So that is what these services let you do. Let's now go ahead and look at them practically. Let's see some of these services that we've discussed. We've talked about security services, right? We've gone ahead and discussed the big data ones, the machine learning ones as well. Let's try and understand them practically and see how do some of those work, or what can you do with these services rather. Okay. So I'm going to quickly switch into my console. So there you go. I've gone back again, and now I'm gonna go ahead and you see this dashboard here. We talked about the management and developer tools as well. So this is how a dashboard, this is what it simplifies, right? What kind of data was being used. So initially when I started the server at 12:30 today, I had a spike there. Okay, so that is gone. That is when I started one of my services. So the CPU utilization rose there. So you can see that the CPU utilization and stuff will change here if you create your resources. Okay, you can monitor other resources, billing and stuff as well. You'd get to know what are the resources. You can see that there are two storage buckets that are there, one compute engine that we created a while ago, and one of the buckets that you saw how to create one, right? So all the information would be available in your dashboards, and this can be done by your monitoring and logging services that you have. Okay, what are the other things that we can do here? Let's just go ahead and take a look at those. Security services, IAM is one of those that I just mentioned, right? So you can create your IAM users here, and you can decide all those things, who gets to access what. So if you click on members roles, you can add those. You can just add users as well. Say for example, I add a user called as Vishal here. Okay, forget the spelling, it's not important. Okay, I can select what kind of role this individual needs to have. Okay, you have to enter the email address here for that. Okay, so you can add an email address, and post that you can decide who gets to access what. Is it an editor access, owner access, viewer access? And I can also add conditions here for durations, times, days, what kind of access and stuff like that. You can add more roles here, and then you can just say save. Once you do that, you can add them in groups as well. You can see that there are members here, right? So you can create groups as well, and then you can add them there. All the policy analyzers and stuff, you'll find all those things here. I mentioned the fact that I'll show you something in AWS as well. So you see, this is the company's account that we use, and I have an IAM user here. Okay, you see, this is signed in by this account. But when I member login, right? If I member login here, it will ask me to do a two-step authentication process. So when I enter the password, it will ask me for a number that would be generated by Google Authenticator on my phone. So it's a multi-factor authentication process, more than one step of authenticating that I am the right user. And since this is a pseudo user that I'm using, I do not have admin access to a lot of services. Say for example, if I open S3 here, it will not let me create a bucket here because I do not have access to that. You see, you don't have permissions to list buckets. So this is what you can control by using your IAM policies, and that is what your IAM services let you do. So I believe this little bit, or this little gist of things, is clear to you people. Okay, moving on, let's try and understand other things as well. Okay, there are other services here as well which you might want to take a look at. If you say sign into the console, it will directly sign in right now because I'm already signed into it. If I wasn't, it would have asked me for all those passwords. And there are other services here as well, right? You have your IAM billing, or basically S3 is something that is similar to the buckets that I've already shown. EC2 is something that lets you create instances here. Okay. And then there are a plethora of services that deal in management and monitoring as well. So if you scroll down, you'll get information about those. You see, you have VPC here, you have CloudFront is one more that should be here or somewhere, which is equal to GCP CDN. And then you have your developer tools. Okay, so you have your code commit, which is similar to the Google repositories, cloud repositories that we saw. So that is what these services let you do, and these basically let you deal with all this data that is there for you to work with. Okay, let's now go back to this thing and take a look at other things as well. So I believe the security bit is clear, management bit is clear to some extent as well for you people. Big data services, we've discussed that there are a lot of big data services here as well. If you scroll down, or if you just go back here and click on services, you'll see that all the other services here. Okay, so we talked about pub/subs as well, right? If you remember. So these are the databases, right? The big table data store, the NoSQL databases that we discussed. You also have your spanner, which is again a database service. SQL is something that stores your SQL data. Monitoring is few things we discussed. Code build is something that lets you develop your code. I've told you, you can build your code there, whatever pieces of code you have. And similarly, if you scroll down, this pops up, right? I talked about topics, subscriptions, and snapshots. You can do all these things by using these particular set of services here as well. Okay, so in terms of APIs as well, I've talked about that there are vision APIs, but again, when you want to use vision APIs and stuff like that, you need to basically activate those APIs, which I don't think are activated here right now. So I'm afraid I would not be able to show you a demo on that, but you can do that. Text to speech is what you can use. For that too, you'll need access, but you can actually go ahead and enable these APIs, and you can actually go ahead and work on these things practically then. Okay. Apart from that, there are other things that you can look into. Some of those are, if you go to AWS, you have services like Poly, which lets you convert text to voice and vice versa. Textract is another one that lets you do that. Then you have Rekognition, which lets you process images. Okay. So if you come here, you can actually go ahead and do all those things, right? Facial analysis, whether a person is happy or not, male or female, right? What could be the age? You can decide you can do face comparison or celebrity recognition as well. So you can compare two images and tell whether they match with each other or not, whether this is a celebrity face and does Google or Amazon know it, right? So these are the things that you can do with these APIs that we discussed. So these are few things that you need to look into. There are quite a few things that you can actually express when you talk about, or explore rather, when you talk about Google Cloud. What I will also do is, as we move further in future content, I will ensure that we come up with videos that talk about these services in detail, and where we'll focus more on each of these services individually. This being a tutorial video, I had to cover a lot of content here, so we could not discuss all those in detail. But in future, definitely we'll come up with more individual videos that talk about this content or those services in particular in detail. As far as this session goes, I believe we've reached its time, and I would be ending this session here. In case if you're interested in Google Cloud certification training and you like structured approach, you can definitely check out Edureka's Google Cloud Platform training, which is a certification training, and we have 24/7 support that would help you in that. Apart from that, if you're interested in similar content, do not forget to subscribe and hit the bell icon to stay notified on the latest content that we have. Thank you.